Calculate the moles of the limiting reactant, Li3N. The problem states that 70 G of solid lithium nitride, Li3N, is reacted with excess hydrogen gas, H2, making Li3N the limiting reactant. The molar mass of Li3N is given as 35 grams per mole. Calculate the initial moles of Li3N present. Moles of Li3N equals mass over molar mass equals 70. G over 35 grams per mole equals 2.0 moles. Use stoichiometry to determine the theoretical moles of LiH produced. Refer to the balanced chemical equation. Li3N plus 2H2 is in equilibrium with Lin2 plus 2 LiH according to the coefficients. 1 mole of Li3N reacts to produce 2 moles of LiH. Therefore, calculate the theoretical moles of LiH that should be formed. Theoretical moles of LiH equals 2.0 moles Li3N times 2 moles LH over 1 moles Li3N equals 4.0 moles. Convert theoretical moles of LiH to theoretical mass in grams. Determine the molar mass of lithium hydride, LiH, using atomic masses from the periodic table. Atomic mass of lithium, Li, approximately 6.94 grams per mole, roughly 7 grams per mole. Atomic mass of hydrogen, H, approximately 1.01 grams per mole, roughly 1 grams per mole. Molar mass of LiH approximately 6.94 plus 1.01 approximately 8.0 grams per mole. Calculate the theoretical yield in grams. Theoretical mass of LiH equals 4.0 moles times 8.0 grams per mole equals 32 grams. Calculate the percent yield. The actual experimental mass of LiH produced is 8.0 grams. Calculate the percent yield. Percent yield equals actual yield over theoretical yield times 100%. Percent yield equals 8.0 grams over 32 grams times 100% equals 0.25 times 100% equals 25%. This identifies option B as the correct choice. The correct answer is option B, 25%.